Right now, you are moving faster than a rifle bullet. Not through space, through the sky above you. If you live near the equator, the ground beneath your bed is carrying you sideways at nearly 1,700 kilometers an hour, and you have never once felt it because everything around you is moving at exactly the same speed. The air, the ocean, the birds mid-flight, the clouds drifting overhead, all of it turning together, silently, the way it has turned for 4.5 billion years. You do not feel this speed for the same reason a passenger does not feel the speed of a smoothly cruising aircraft. Motion is only felt as a change, an acceleration, a jolt, a shift. Shared, constant motion disappears from the senses entirely. It becomes simply the world, the fixed backdrop against which everything else happens. You have never had a reason to notice it, because nothing has ever asked you to. What if it stopped, not slowed gradually, the way a spinning top loses momentum to friction over minutes? Not wobbled, the way the planet's axis genuinely does drift over long cycles, in movements too slow and too small for any person to sense. Stopped the planet's rotation brought to zero, all at once, while everything resting on its surface, everything moving with it, kept the speed it already had a moment before. Tonight, we follow that single change through the first seconds, the first hours, and the first months of a world that no longer turns on its axis. We will watch what happens to an ocean asked to keep its momentum while the seafloor beneath it does not. We will watch what happens to weather systems that have never, in the planet's entire history, operated without the invisible curling hand of rotation guiding them. We will watch a day stretch from 24 hours into something closer to a season, and a season into something closer to a permanent condition. And in the final chapter of this documentary, we will ask a second question, one that may be stranger than the first. What happens if, after roughly half a day of stillness, the Earth begins to spin again just as suddenly, just as completely as it stopped? This is not, in the end, a story about the end of the world. It is a story about momentum, about what a planet carries with it, invisibly, every single day, and about what becomes visible only in the instant that momentum is taken away. We will move through this slowly, the way the planet itself, in this scenario, is not permitted to. And we will not look away from the parts that are difficult to sit with, because the physics does not offer us that option. Consider, for a moment, everything currently sharing that 1,700 km/h motion with you, without any of it feeling like motion at all. The aircraft currently crossing an ocean at cruising altitude, the satellites in low orbit, moving to their own separate rhythm but still launched from, and eventually returning to, a rotating world. The water in every harbor, every lake, every glass sitting undisturbed on a table, all of it sharing the same inherited speed, all of it perfectly, invisibly synchronized. This synchrony is not a small thing. It is the reason a plane can take off from one city and land in another without either city having moved out from under the flight path in the meantime. It is the reason a ball thrown straight up returns to the same hand that threw it, rather than landing somewhere far to the west. Rotation is so deeply built into the ordinary experience of being on this planet that removing it, even hypothetically, forces us to notice 1,000 small things we had never previously had any reason to notice at all. There is a particular comfort in documentaries built around deep time in the slow unfolding of an extinction event across millions of years, in the gradual drift of continents across an ocean that has all the patience in the world. This documentary asks something different of you tonight. It asks you to sit with a change that happens all at once, and then to follow its consequences as they slow, gradually, from seconds into hours into months, a compression of deep time's usual patience into a single, unbroken night. The rhythm of this story is unusual for this channel. Its underlying subject, the quiet architecture holding an ordinary world together, is not. Every what if this channel has ever asked has, at its center, the same quiet purpose: to make visible something the ordinary world keeps hidden simply by working correctly. An extinction event reveals how fragile a food web actually is, long after the fact. A vanished ocean reveals how much of a coastline was never solid ground to begin with. Tonight's question does something similar, only faster and closer to home than most. It does not ask you to imagine some distant era of the planet's past. It asks you to imagine losing something you are relying on at this very moment, without having ever noticed you were relying on it at all. Let us begin in the last ordinary second, the one just before everything changes, and nobody yet knows it. Before the countdown begins, it is worth pausing on what stopped actually means in a scenario like this one, because the phrase hides a great deal of complexity beneath its simplicity. Earth's rotation is not a surface phenomenon, the way a coin spins on a tabletop while the table itself remains still. The entire planet turns together, the solid inner core, the molten outer core surrounding it, the slow-moving mantle, the rigid crust we stand on, the oceans resting across that crust, and the atmosphere layered above all of it. Every one of these layers shares, in ordinary conditions, the same underlying rotational motion, each completing one full turn in roughly 24 hours, locked to the others by gravity and by the physical connections between them. For the purposes of this documentary, we are treating the stop as instantaneous and total. Every layer of the planet, from the inner core outward to the edge of the atmosphere, halts its rotation in the same single moment. This is, it must be said clearly, not something that has ever happened, and modern physics offers no known mechanism by which it could occur. Nothing we understand about gravity, about planetary formation, about the forces that act on a body the size of Earth, suggests a pathway to this event actually taking place. But the value of the question was never in its plausibility. It is in what the answer reveals about the planet we already inhabit, because to understand what would be lost in an instant, we first have to understand, in detail, everything rotation quietly provides. The Coriolis effect that gives storms their shape and ocean currents their circular paths. The magnetic field, generated deep within the planet's molten core, that shields the surface from the harshest of the sun's radiation. The simple, daily alternation of light and dark that every living system on the planet has built its rhythms around, for as long as there has been life to keep rhythm at all. Remove the rotation, and none of these things vanish immediately. They begin, instead, to unravel, some in seconds, some in hours, some over months or years, far beyond the scope of what a single night's documentary can follow in full. We are going to trace the fastest and most immediate of these unravelings closely, hour by hour, and touch the slower ones only as far as the first months allow us to see. Each chapter ahead marks a boundary in that unraveling, not a hard line, but a rough marker, the point at which one kind of consequence gives way to the next, slower kind. One further clarification before the countdown begins. The scenario does not assume any change to the planet's mass, its gravity, or its orbit around the sun. Only the rotation is removed. Earth continues circling the sun exactly as it always has, at exactly the same distance, on exactly the same yearly schedule. What changes is narrower, and in some ways stranger for its narrowness. The planet keeps traveling, but it stops turning as it travels. Everything that follows tonight grows from that single, isolated change. It is also worth being honest about what this documentary is and what it is not. It is not a forecast, and it carries no warning attached to it. It borrows the structure of a countdown, because a countdown is one of the clearest ways to walk through cause and consequence slowly, one step at a time, without losing the thread connecting an opening instant to everything that follows from it across the hours and months ahead. Nothing about the shape of this story should be mistaken for a claim about what is likely, or even possible, in the world outside it. The clock starts now, the first 5 seconds. At the equator, the ground was moving at just over 460 meters per second when it stopped, nearly 1,700 kilometers an hour, faster than the cruising speed of a commercial jet, faster than the speed of sound in the air around it. Everything not fixed rigidly to that ground kept moving at that same speed, because nothing in the laws of motion asks permission before it continues. Objects in motion remain in motion unless something acts to stop them. And in the first fractions of a second after the planet's rotation ceased, almost nothing on the surface had yet been acted upon. Only the ground itself had changed. This is the same principle that throws a passenger forward when a car brakes hard, scaled up until the vehicle in question is an entire planet, and the passengers are every ocean, every forest, every city, every person standing on solid ground. In the first second, the ocean did not stop. Water is not rigid the way rock is rigid. It does not share a single, unified motion across its entire mass, the way a solid body does. It slides against itself. It folds. It lags behind whatever contains it. As the seafloor beneath the ocean lost its rotational speed instantly, the water resting above it did not, and a body containing more than 1 billion cubic kilometers began, in that first second, to slide across a seabed that could no longer keep pace with it. This was not yet a wave in the ordinary sense, no single crest, no single trough. It was closer to the entire ocean being treated, for a moment, as one continuous object with nowhere to place its inherited motion except forward. On land, the effect was more immediate and, in some ways, easier to picture clearly. Anything not bolted into bedrock vehicles in transit, structures resting on looser foundations, loose soil, unanchored objects of every kind, and the unanchored bodies of every living thing standing on open ground continued moving east at the speed the ground had been carrying them a moment before. A person standing at the equator, in this scenario, would not gently drift out of place. They would be thrown instantly and without warning, at a speed comparable to the winds inside the most severe hurricanes ever recorded, except, in this first instant, the air around them would still be moving at very nearly that same speed too, which is the only small mercy contained anywhere in this opening moment. The catastrophe of these first seconds was not yet primarily about wind. It was about every solid, unanchored thing on the planet's surface attempting to continue in a straight line while the ground beneath it had already, in an instant, changed its motion completely. The atmosphere itself, layer upon layer of it, extending more than 100 kilometers above the surface, before thinning into the vacuum of space, held its rotational speed almost entirely intact through these first several seconds. Air has mass, but far less of it, pound for pound, than rock or water, and it takes a measurable amount of time for a sudden change in the ground's motion to transfer upward into a corresponding change in the motion of the air above it. For the first 5 seconds of this scenario, the sky, in a very real sense, did not yet know what had happened to the ground beneath it. Buildings anchored deeply into stable bedrock experience this differently than structures resting on loose soil or reclaimed coastal land. Deep foundations transferred the sudden stop upward through a structure violently but coherently, not sliding, but shaking. The way a struck bell rings from a single sharp impact, the vibration moving through the whole form at once. Structures built on unstable ground, by contrast, were more likely to have their foundations effectively let go beneath them in these opening seconds, the building's own mass continuing to move, even as the loose ground it stood upon had already come to a complete stop. At the poles, almost none of this applied in the same way, and this detail matters more than it might first appear. Rotational speed decreases steadily towards zero as a location approaches either pole, because a point closer to the planet's axis simply has less distance to cover in each rotation, and therefore less speed to lose when that rotation ends. A person standing at the exact geographic North Pole in this scenario would have felt almost nothing in these first 5 seconds, no significant lateral motion to lose, because there had been almost none to begin with. This tells us something important about the shape of the disaster to come. It would not strike the planet as a single uniform catastrophe, delivered equally to every latitude. It would strike hardest and fastest at the equator, and fade gradually toward almost nothing at the poles, an event with geography built into its severity from the very first instant, unevenly distributed, the way almost nothing else about this scenario would be unevenly distributed by comparison. Aircraft in flight, in these opening seconds, occupied a strange position within the unfolding event. An aircraft cruising at altitude was, like the atmosphere around it, still carrying its full rotational speed, largely undisturbed in this first moment, but the ground beneath it, the runways it would eventually need to land on, had already stopped. In the seconds that followed, this discrepancy would become one of the most immediate and dangerous complications of the entire event, though its full consequences would not become clear until slightly later in the sequence we are following. By the 5th second, the ocean's surface had begun to visibly deform, not yet a wave in the traditional sense, but a slow, planetary-scale tilting, water piling subtly higher in the direction its inherited momentum still carried it. The atmosphere directly in contact with the surface had begun to shear against the layers above it, a friction-driven displacement that marked the earliest motion of what would become within the next half-minute. Wind unlike anything in Earth's recorded history. Consider a detail easy to overlook amid the scale of everything else: the water in a still glass sitting on a table. In the first instant, that water, like the ocean, carried its own inherited motion, and the table beneath it had already stopped. The glass itself, resting on the table, would have been thrown along with everything else unanchored to bedrock, a small, almost trivial echo of the same physics reshaping entire coastlines at that same moment, playing out identically in millions of ordinary rooms around the planet's equatorial band. A cup of tea left cooling on a nightstand, a bowl of water set out for a pet. The physics does not distinguish between the largest ocean and the smallest, most forgettable container. Momentum, once set in motion, asks the same question of everything carrying it. Animals caught in the open in these first seconds experienced the event with no more warning than any person did. A bird in flight, sharing the atmosphere's inherited motion, was for a brief window no more disturbed than the air around it, but any animal in contact with the ground, running, standing, resting, was thrown exactly as any unanchored object was thrown, with no distinction made by the physics between a person, a herd of grazing animals, or a loose stone. This is one of the quieter cruelties of a scenario built on pure momentum. It does not discriminate. It acts identically on everything not held down by something stronger than its own inherited speed. Objects in orbit, curiously, were among the least affected by these opening seconds. A satellite circling the planet at several kilometers per second was moving under an entirely different set of physical rules than anything resting on the surface, its motion governed by orbital mechanics, by the balance between gravity and velocity, rather than by the planet's rotation directly. The International Space Station and the constellation of satellites surrounding the planet continued along their paths as though nothing at all had happened, at least for these first several seconds. Their reckoning with this event, if it came at all, would arrive later, indirectly, through changes to the ground stations and atmospheric conditions they depended on to stay in contact with the surface below. There is a way of understanding this first 5 seconds that has nothing to do with destruction, and it is worth sitting with before we move forward into the more violent minutes ahead. Momentum is not an abstract concept invented to explain disasters. It is the same principle that lets a spinning bicycle wheel resist being tipped over, the same principle that keeps a thrown discus flying level rather than tumbling end over end. For 4.5 billion years, the planet's rotational momentum has simply been a fact, as constant and ordinary as gravity itself. In these first 5 seconds, it stopped being ordinary, and every object on the surface, from the largest ocean to the smallest pebble, was suddenly required to answer the same question at once. What do you do with speed? You no longer have anywhere to put. It helps, here, to hold a few numbers together at once, because the unevenness of this event is easiest to grasp through direct comparison. At the equator, the surface speed lost was close to 1,700 kilometers an hour. At a latitude roughly midway between equator and pole, a line passing near many of the world's major cities, that speed was closer to 1,200 kilometers an hour. Still catastrophic, but measurably gentler than the equatorial extreme. Closer still to either pole, speeds fell toward only a few hundred kilometers an hour, and finally, at the poles themselves, toward nothing at all. The planet, in these opening seconds, did not experience one disaster. It experienced a gradient of disaster, precisely proportional to distance from its own axis, a detail with no exceptions and no mercy built into it beyond the geometry itself. The physical principle underlying all of this has a name simple enough to hold in a single sentence. An object in motion continues in that motion unless something acts upon it. It is the same idea taught in the most basic study of physics, usually through small, unthreatening examples: a ball rolling across a table, a cart released down a gentle slope. Scaled up to encompass an entire planet's ocean, atmosphere, and every loose object upon its surface, the principle does not change in the slightest. Only its consequences do. Deep within the planet, far below anything these opening seconds could visibly affect, the solid inner core, a sphere of iron and nickel roughly the size of the moon, suspended at the very center of the Earth had, under the terms of this scenario, also lost its rotational motion in the same instant as everything above it. Unlike the surface, where the loss of motion produced immediate and visible chaos, the inner core's stillness would remain, for now, entirely undetectable from anywhere a person could stand. Its consequences belonged to a much longer time scale than these first 5 seconds could ever reveal. But the change itself, silent and hidden, had already taken place. There is a stillness worth noting even within this chapter of pure violence, the brief, genuine silence that existed in the fraction of a second between the moment rotation stopped and the moment its consequences became audible. For less than the blink of an eye, before the wind found its voice and the ocean found its new momentum, the world was, in the most literal sense, quieter than it had ever been. In its entire recorded history, a silence with no witness, gone before anyone could register that it had occurred at all. The crust itself, in these opening seconds, absorbed a kind of stress geologists have no ordinary category for. An earthquake, in the conventional sense, releases energy that is built up slowly along a fault line over years or decades. Energy stored in rock bent gradually past its ordinary tolerance. What happened to the crust in this event was different in kind, not a slow build releasing suddenly, but an instantaneous change in the motion of the entire planetary body transmitted through solid rock, the way a shockwave moves through any rigid material struck without warning. In places where the crust was already under stress from ordinary tectonic activity, this added transmission was enough to trigger immediate rupture. In more stable regions, the rock absorbed the shock as a deep, resonant vibration, felt everywhere at once rather than radiating outward from any single point. Unlike any earthquake in the historical record, which always has an origin, a specific point from which its energy spreads. Skyscrapers and other tall structures, engineered to sway gently under wind load and even under the slower, rolling motion of a conventional earthquake, faced a very different kind of stress in this instant, not a rolling wave moving through the ground, but the ground itself abruptly changing velocity beneath the structure's foundation while the building's own mass, high above, continued to carry its prior motion. The taller the structure, generally, the greater the discrepancy between what the foundation experienced and what the upper floors experienced. A mismatch that ordinary structural engineering, calibrated to earthquakes and wind rather than to a sudden and total loss of planetary rotation, had never been designed to accommodate. Time itself, in the practical sense the word is normally used, ceased to mean quite the same thing in this first moment. Time zones exist because the planet turns, dividing the day into segments corresponding to a given location's position relative to the sun. With that turning gone, the entire structure, underlying the concept of a time zone, lost its foundation within these same first seconds. A detail with no immediate physical consequence, but one that would, in the days ahead, complicate every attempt to coordinate a response to everything else this event had set in motion. Underground, in the tunnels and mines carved into the crust by human activity, this first moment played out with a strange, muffled quality distinct from the open surface above. Rock, unlike air or open water, transmitted the shock of the sudden stop as a single sharp jolt rather than a sustained and building force, briefer in its initial violence than what unfolded above ground, though what followed in these enclosed spaces depended heavily on how well their surrounding structure had been reinforced against sudden shifts in load. A question answered differently in every mine, every tunnel, every subterranean space on the planet, according to standards that had never once considered a scenario like this one. It is worth pausing, briefly, on what this first 5 seconds does not include, because absence is its own kind of information. Nothing about temperature had changed meaningfully in this window. The heat generated by friction was still only beginning to accumulate, nowhere near the scale it would reach within the hour. Nothing about the length of the day had changed yet either, since the consequences of a fixed sun would only become apparent as the hours themselves accumulated. This opening chapter belongs entirely to momentum and to nothing else. Everything gentler and everything slower still lay ahead. Even the planet's shape, in the most technical sense, carried a quiet record of its rotation before this event began. A spinning planet bulges very slightly at the equator and flattens very slightly at the poles, a subtle distortion caused by the outward pull of rotational motion acting against gravity's inward pull. That bulge, present in Earth's actual measured shape for as long as the planet has spun, would not vanish instantly at the moment rotation stopped the solid crust, rigid and slow to respond, would carry the memory of that shape for a long time after the force that created it had gone. A small, geometric echo of rotation persisting quietly even after everything else about that rotation had already been lost. 5 seconds. That is how long it took for planetary rotation, a constant so old, so deeply woven into the physical structure of the world, that it predates complex life itself, to become the single most urgent fact governing every living thing's next several hours. The first half minute. By the time 30 seconds had passed, the atmosphere had begun, in earnest, to catch up to what the ground already knew. Air does not stop the way solid rock stops. It carries mass, but it is loosely bound, free to slide against itself in ways stone cannot. As the lower atmosphere, now in direct contact with the stationary ground, began to slow through friction, the layers above it did not slow at anything close to the same rate. This produced what meteorologists, under ordinary circumstances, would recognize as wind shear, the difference in wind speed and direction between adjacent layers of air, except occurring here at a scale and a violence with no precedent in the planet's recorded history. Surface winds near the equator, in these first 30 seconds, climbed toward speeds approaching the planet's own former rotational velocity, over 1,600 kilometers an hour, faster than the speed of sound. At that speed, wind stops behaving like a weather event and starts behaving like a demolition. Vegetation, loose structures, exposed topsoil, anything not bound directly to solid rock, was stripped from the surface and carried with it. This mechanism, wind, sustained and extreme, rather than any single dramatic instant of fire or flood, accounts for the majority of surface devastation across this early period, because the atmosphere, unlike the ocean, had almost the entirety of the planet's former rotational momentum still to lose, and very little time in which to lose it gently. The ocean, meanwhile, had moved beyond mere tilting. The initial deformation of the first few seconds had become motion in its own right, a vast mass of water, already displaced, now drawn by gravity back toward some new equilibrium, but doing so unevenly across ocean basins spanning thousands of kilometers in every direction. This produced surges, not a single wave, but a sequence of them, arriving at coastlines with a force closer to an advancing wall of water than to any tsunami on record, because unlike an earthquake-driven tsunami, which displaces water at one specific location and lets that displacement radiate outward, this event had displaced the momentum of an entire ocean simultaneously, everywhere at once. At coastal regions nearest the equator, where both the wind and the water's inherited momentum reach their most extreme values, the two effects arrive together, compounding rather than merely adding. This half-minute stands as the single most violent period for any region on the planet's surface. Anywhere in this entire scenario, a compound event, wind and water acting on the same coastlines in the same moments, neither one waiting politely for the other to finish before beginning its own share of the damage. Higher latitudes experienced a gentler version of the same underlying physics, though gentler is a relative term here and should not be mistaken for mild. A city at the latitude of, for instance, the northern reaches of Europe or the southern tip of South America had been moving at only a fraction of equatorial speed to begin with, and so its wind and wave effects, while still severe by any ordinary historical measure, did not approach the scale of devastation occurring nearer the equatorial band. There is a temptation, in a scenario constructed like this one, to describe the destruction in vivid detail and stop there. But the value of walking through these minutes slowly, carefully, is in the physics underneath the destruction, not in the destruction for its own sake. What is happening across this half-minute is momentum finding somewhere to go. It cannot be created and it cannot be destroyed, only transferred, redirected, and gradually dissipated as heat and motion, and eventually a form of stillness the planet has not experienced before. The half-minute we have just walked through is the planet, in the earliest stages of that long redistribution, still holding almost all of the kinetic energy it carried a minute earlier, with almost none of it yet converted into anything resembling calm. Aircraft caught in flight during this window faced conditions unlike anything in aviation's history. The extreme wind shear developing at every altitude made stable flight, for aircraft already airborne when the event began, a matter of chance as much as skill sum. At higher altitudes where the atmosphere had not yet begun its own violent adjustment, would have several more minutes of relatively stable air before the disruption reached them. Others, closer to the surface, encountered the leading edge of the disruption almost immediately. To understand the scale of wind at these speeds, it helps to set it against something familiar. The strongest hurricanes ever recorded on Earth's surface sustain winds in the range of 200 to 300 kilometers an hour at their absolute peak, and even those storms are capable of leveling entire coastal settlements. The winds present across the equatorial band in this first half-minute exceeded those figures several times over, and unlike a hurricane, which is a localized, rotating system with a defined edge and a calmer center, this wind was continuous, planet-circling, and without any eye of relative stillness anywhere within it. Ports and harbors, wherever they were positioned relative to the advancing surge, faced some of the most concentrated destruction anywhere in this half-minute. Ships at anchor, tied to fixed moorings, were subjected to forces the moorings had never been engineered to withstand, while ships still underway found themselves caught in water moving in ways no navigational chart or instrument had ever needed to account for. The concept of a calm harbor, a place of shelter from open water, briefly ceased to have any meaning at all. Aircraft still airborne during this half-minute faced conditions that varied enormously depending on altitude and position. Those cruising at high altitude, above the thickest and most turbulent layers of the lower atmosphere, experienced a delayed and somewhat gentler version of the disruption, buying their crews and passengers a narrow window of relative stability that would not last. Those closer to the ground, particularly aircraft in the earliest or final stages of a flight, encountered the leading edge of extreme wind shear almost immediately, a condition aviation, in the ordinary course of its history, has never had to design against. There is also a quieter, more atmospheric dimension to this half-minute worth pausing on: sound. Wind at these speeds does not simply move air. It generates noise on a scale closer to that of a sustained, planet-wide roar than to any storm within living memory, a sound with no clear origin point, because it was arising simultaneously from every point along the equatorial band at once, felt as much through the body as heard through the ears. Beneath the visible destruction of this half-minute lies a simple thermodynamic truth worth stating plainly. Energy does not disappear, it only changes form. The kinetic energy the atmosphere had carried in its rotation, once it began grinding against a stationary surface, converted steadily into heat friction at a planetary scale, behaving exactly as it does at the scale of two hands, rubbed briskly together, only multiplied across an entire globe's worth of moving air, meeting an entire globe's worth of suddenly still ground. In certain regions, particularly where wind-driven debris met exposed dry vegetation, this friction-generated heat was sufficient to ignite fires, adding smoke and flame to a scene already dominated by wind and water, though fire, in this early half-minute, remained a secondary rather than primary source of destruction. Large-scale infrastructure, dams, bridges, elevated roadways faced forces during this half-minute that their original engineering had never accounted for, because no engineer, in the ordinary course of designing such structures, has ever needed to plan for wind approaching the speed of sound arriving simultaneously with a surge of ocean water. Dams positioned near coastlines, built to hold back river systems under ordinary flow conditions, encountered a reversal of pressure entirely outside their design tolerances, as displaced ocean water pushed inland through river mouths and estuaries. The planet's major ocean currents, vast, slow-moving rivers within the sea itself, responsible under ordinary conditions for redistributing heat across enormous distances, found their driving mechanism removed in this same half-minute. These currents depend heavily on the same Coriolis effect the wider ocean had already lost, and their disruption, while less visually dramatic than the surges striking coastlines, represented an equally significant unraveling of a system that had operated essentially unchanged for longer than any land-based civilization has existed. The long-term climatic consequences of this particular loss would not become apparent for months, but the mechanism generating them had already, within this half-minute, ceased to function as it once had. There is a texture to this half-minute worth naming plainly. Dust and displaced soil, torn from exposed ground across entire continents simultaneously, thickened the lower atmosphere in ways that would have been visible from orbit, as a haze spreading outward from every continental interior, a fine particulate signature of the wind's work, layered on top of the more dramatic imagery of storm and surge. Geography shaped this half-minute as much as latitude did. Regions already prone to seismic and volcanic activity, the long chain of fault lines and volcanoes encircling much of the Pacific Ocean, for instance, faced a compounding of hazards during this window. Wind and surge arriving on top of ground already unstable, from the crustal stress described in the opening seconds. Vast, low-lying river basins, by contrast, home to some of the densest concentrations of life on the planet, absorb the surge in a different way entirely, water pushing inland along the natural pathways these basins had always provided, extending the reach of the ocean's disruption far beyond the immediate coastline itself. Arid interior regions, far from any coast, experienced this half-minute primarily through wind alone, no surge to contend with, but dust storms of a scale and duration without precedent. Entire landscapes lifted and repositioned within a matter of seconds. Sheltered valleys and topographically enclosed regions fared measurably better than open plains and exposed coastal plateaus during this half-minute, a detail that offers one of the first hints of an uneven pattern to the disaster beyond simple latitude. Terrain itself, in these opening minutes, had become a form of protection or exposure almost as significant as distance from the equator. A valley ringed by higher ground could deflect and dissipate wind that would otherwise have swept through unimpeded, while a flat, open plain offered nothing to interrupt or slow the same wind's path. Beneath the ocean's violently disturbed surface, the deep abyssal plains, the vast, Flat seafloor regions covering much of the planet beneath several kilometers of water remained, throughout this half-minute, comparatively undisturbed. The chaos, playing out at the surface, driven by momentum and wind, had not yet had time to propagate downward into these deeper layers, a detail that would matter increasingly as the following hours revealed just how much of the ocean's total volume sat below the reach of the most immediate violence. Rivers, across the affected regions, behaved in these 30 seconds in a way with almost no precedent in hydrology. Ordinarily, a river's flow is governed by gradient, by the slope of the land it moves across, always traveling from higher ground toward lower. The surge pushing inland from the coast, arriving with tremendous force from the direction the river ordinarily emptied into, reversed that flow entirely in many major waterways, sending river water backward, upstream, sometimes for tens of kilometers, before gravity and the retreating surge eventually reasserted the river's original direction. Forested regions, particularly dense equatorial rainforest, absorbed this half-minute's violence differently than open terrain. The sheer density of vegetation created enormous surface drag against the wind, dissipating some of its force, but at a tremendous cost to the forest itself. Canopy layers stripped away almost entirely across enormous areas, the accumulated growth of centuries removed within the span of half a minute. What had been, an hour earlier, some of the most biodiverse regions on the planet's surface faced, by the 30th second, a transformation more sudden and more total than anything in the geological record of comparable ecosystems, even accounting for the most severe wildfires or storms in recorded history. The particular sound of this half-minute, layered beneath the roar of the wind itself, included something closer to a continuous low groan, the sound of stressed rock and shifting earth, audible wherever the wind briefly permitted anything else to be heard at all, a sound with no true equivalent in the planet's ordinary catalog of natural noise. Desert regions, paradoxically, offered some of the least destructive ground anywhere on the planet during this half-minute, not because the wind spared them, but because there was comparatively little standing structure or established vegetation left for that wind to destroy. Sand itself simply moved, redistributed across enormous distances, reshaping dune formations that had held their general position for centuries into new configurations within a matter of seconds, a form of transformation without the same human or ecological cost carried by the destruction unfolding. Elsewhere, though no less total in its own physical terms, islands, particularly smaller and lower-lying ones, faced a compounded set of risks during this half-minute that larger land masses were partially spared. With less interior distance to absorb or redirect the incoming surge, and often minimal elevation to offer refuge above the rising water, many smaller islands experienced near-total inundation within this window, their entire visible landmass temporarily submerged beneath water, still carrying the ocean's inherited momentum. Before beginning, in the following minutes, the slow process of that water's partial retreat, mountain ranges, by contrast, offered some of the only genuine refuge available anywhere on the planet's surface during this half-minute. Elevation alone did not stop the wind, which reached even the highest peaks with force, but it did place a meaningful distance between higher ground and the ocean's surge, and the sheer physical bulk of a mountain range served, in places, as a partial barrier against wind that had swept unimpeded across flatter terrain for hundreds of kilometers beforehand. Snow and ice at high altitude, dislodged by both the initial shock and the extraordinary wind, now sweeping across even the most sheltered mountain valleys, triggered avalanches across mountain ranges worldwide. Within this same half-minute, a hazard entirely separate from the ocean's surge, striking regions the surge itself could never reach, adding one more category of danger to a list already longer than any single chapter of this documentary could hope to fully catalog. By the 30th second, coastal regions across the planet had already become unrecognizable relative to the world they had been a minute before. The wind had not yet reached its peak. The water had not yet found anything resembling a new level. And the atmosphere, vast as it is, had absorbed only a small fraction of the motion it would eventually need to shed before anything resembling calm could return. The first hour, an hour is long enough for a planet to begin negotiating with itself. By this point, the sheer violence of the first half-minute had begun, gradually, to ease, not because the underlying energy had disappeared, but because it had started to spread across a wider system. And spreading, at this scale, looks very much like slowing, even when the total energy involved has barely changed. Wind speeds at the equator, while still far beyond anything in recorded meteorological history, had begun to fall from their initial peak as friction against the now stationary surface steadily converted raw motion into heat. This is a slow process even at extreme scale. An hour into the event, the atmosphere was still moving considerably faster near the surface than the ground directly beneath it, and the storms this discrepancy produced were continuous, covering nearly the entire equatorial band in what would have appeared, from orbit, as a single unbroken system of extreme weather encircling the planet. The ocean's surges, meanwhile, had begun to organize into something closer to a new, though still temporary shape. Water that had been thrown towards certain coastlines in the opening minute was already retreating, pulled by gravity back toward a new equilibrium. But equilibrium, in this context, does not mean a return to where the water had started. The absence of rotation meant the absence of one of the deepest organizing forces the ocean had ever known, the Coriolis effect, the subtle rotational influence that curves winds and currents, that gives hurricanes their characteristic spin and ocean gyres their slow, circular paths across entire basins. Without it, the deep patterns governing how heat and water move across the planet's surface no longer applied in the way they always had. An hour in, the ocean was not simply damaged in the way a coastline is damaged by a storm. It had lost the organizing principle that had shaped its behavior for longer than there has been complex life on Earth to witness it. Something else was becoming visible in this first hour, quieter and less immediately dramatic than wind or wave, but carrying consequences that would only grow with time. The question of the planet's interior, whether it had stopped in the same instant as the surface, depends on how literally one takes the premise of this scenario. Taken at its most complete, every layer stopping together in a single moment, the outer core stopped as well, the molten iron layer whose slow, churning motion generates Earth's protective magnetic field. That field does not collapse within a single hour. It is sustained by a deep and gradual process, and its decline would unfold over a timescale far longer than the hour we are currently inside. But the process had already begun, quietly, in a place no instrument on the surface could directly observe, and it is worth naming here, in this first hour, because everything that follows in the chapters ahead builds outward from this same invisible starting point. Seismic activity had also begun to register across the globe by the end of this hour, not because the ground itself had fractured from the stopping event directly, but because the sudden redistribution of an entire ocean's mass exerts real pressure on the crust beneath it, adding enormous new weight of water in some regions while removing it almost entirely in others. The crust responds to changes in load the way it always has, slowly and along existing fault lines rather than through any single dramatic rupture. And by the close of this first hour, some of those fault lines, already under stress from ordinary tectonic forces, had begun to slip. There is a quieter image worth holding on to here, amid everything violent this chapter has described. In regions far from any coastline, deep in the interior of the largest continents, an hour into this event looked different than it did anywhere near the ocean. The wind was still severe, still far beyond historical precedent, but the compounding violence of wave meeting wind that had defined the coasts in the opening minutes was, in these interior regions, simply absent. The devastation here was slower, more singular in its cause, and in that sense, marginally more survivable, a detail that would matter a great deal in the weeks and months that followed, though its full significance would not become clear until much later in this documentary. The jet streams, the narrow, fast-moving rivers of air high in the atmosphere that ordinarily steer weather systems across entire continents, depend heavily on the same Coriolis effect the ocean had already lost. An hour into this event, those streams had begun to break down, their once organized paths dissolving into something far less predictable. This mattered enormously for what would come in the following days and weeks, because the jet streams are one of the primary mechanisms by which the planet ordinarily moves heat from the equator toward the poles. Their breakdown, occurring quietly within this first hour, was an early sign of the deeper climatic reorganization the months ahead would bring. Communication across the globe, in this first hour, had already become fractured in ways separate from the physical destruction itself. Satellite-based systems, largely undisturbed in their own orbits, continued to function, but the ground stations and surface infrastructure receiving their signals had, in many regions, been damaged or destroyed by the same wind and water reshaping the coastlines. Radio communication, dependent in part on atmospheric conditions that had themselves become extreme and unpredictable, suffered its own degradation, layered on top of the physical damage to towers and stations. An hour in, the ability of any single region to know, with confidence, what was happening in any other region had already been substantially reduced. Volcanic regions, particularly those already considered geologically active before this event began, showed early signs of disturbance by the end of this hour, driven by the same crustal stress produced by the ocean's dramatic redistribution of weight. This is not a claim that volcanic eruptions occurred within the first hour. Specifically, that timescale belongs more properly to the days and weeks that would follow, beyond the immediate scope of this chapter, but the underlying stress, the slow flexing of a crust, suddenly carrying its water in entirely different places than it had an hour before, had already begun in earnest. From orbit, had anyone been positioned to observe the whole planet at once in this first hour, the image would have been unlike anything in the archive of Earth photography accumulated over the preceding decades. Bands of storms circling the equator, without any of the organized, swirling structure of an ordinary hurricane. Coastlines already visibly altered by surge and retreat. And beneath it all, entirely invisible to any camera, the beginning of a magnetic transformation that would not become measurable in its full consequence for months or years to come. High above the surface, the ionosphere, a layer of the upper atmosphere charged by constant interaction with the sun's radiation, began, within this first hour, to behave in ways that departed from its ordinary, well-understood patterns. This layer plays a quiet but essential role in long-distance radio communication, reflecting certain signals back toward the surface across great distances. Its disturbance, tied to the same broader atmospheric upheaval unfolding below it, compounded the communication difficulties already caused by the physical destruction of ground-based transmission towers. Groundwater systems, far less visible than the ocean's surges but no less affected by this hour's events, responded to the sudden redistribution of surface water pressure in ways that would only become apparent over subsequent days. Aquifers in some coastal regions receiving sudden influxes of saltwater intrusion as the surges pushed inland, altering water tables that had remained stable for centuries in the span of a single hour. Migratory species already in transit when this event began, birds partway through seasonal migration spanning thousands of kilometers, whales following routes memorized across generations, found themselves within an atmosphere and an ocean no longer behaving as the routes they depended on. Navigation systems built into these animals over long evolutionary histories, some relying in part on the Earth's magnetic field, others on established current patterns or prevailing winds, faced a first hour in which nearly every one of those underlying assumptions had shifted beneath them. For any system attempting to track the positions of satellites from the ground, a task requiring precise knowledge of the observer's own location and orientation relative to the stars above this first hour introduced a compounding confusion. The satellites themselves continued along their unaffected orbital paths, but the ground stations attempting to communicate with them now sat beneath a turbulent, rapidly changing atmosphere that distorted and disrupted the signals passing through it, adding one more layer of difficulty to an already fractured global picture of what, exactly, was happening and where. The ocean's overturning circulation, the slow, deep exchange of water between the surface and the depths that ordinarily takes place over centuries, driven by differences in temperature and salinity as much as by rotation, had not yet been meaningfully disrupted by the end of this first hour. This deep, patient circulation operates on a timescale so much longer than the events of this single hour that it remained, for now, one of the very few ocean systems still behaving according to its old rules, a slow exception in a planet otherwise being remade at tremendous speed. Without the Coriolis effect to organize atmospheric circulation into the recognizable rotating storm systems familiar from ordinary weather, the air across the equatorial band had, by this hour, begun instead to organize into something closer to simple convection cells, hot air rising, cooler air sinking, moving in relatively straight patterns rather than the great curling spirals a hurricane or a cyclone would ordinarily display. This is, in essence, the same basic process that drives circulation on planets or moons with little or no rotation of their own, a pattern more commonly discussed in the context of other worlds entirely, now playing out for the first time in Earth's own atmosphere. Plant life exposed directly to the earliest hour of extreme wind faced a simpler, more immediate threat than anything related to the longer climatic disruptions still to come. The sheer mechanical force of the wind itself, capable of stripping leaves, snapping trunks, and uprooting even well-established trees across enormous areas in a matter of minutes. A purely physical toll that would already, by the end of this hour, have reshaped the visible landscape of entire regions, independent of anything the following months would bring. At the poles, by contrast, this first hour passed in relative, though not complete, calm. The dramatic loss of rotational speed that had devastated the equatorial band had never applied here in the same way, and while the broader atmospheric disruption would eventually reach even these furthest latitudes, the polar regions experienced this particular hour as something closer to a distant disturbance than a direct assault, a detail that would shape which parts of the planet held on to some semblance of stability longest as the scenario continued to unfold. The polar ice caps themselves, vast and ancient, registered almost nothing structurally different in this first hour compared to any other. Ice, unlike ocean water, is rigid, bound together as a single connected mass rather than a fluid free to slide and surge. It had shared the same rotational speed as everything else before the stop, but because that speed had been so much lower at these latitudes to begin with, the ice sheets experienced the transition with a mildness the equatorial ocean never had the option of. By this hour, the earliest indications of a broader shift in the planet's total energy balance had begun to appear, though no single instrument or observer could have registered the full picture at once. Energy that had, for the entirety of the planet's history, been distributed by rotation, carried from the equator toward the poles by winds and currents organized around that spin, now had no reliable mechanism for reaching the poles the way it once had. Heat was beginning to accumulate where it fell, rather than circulating onward the way it always had. This single change, more than any individual storm or surge, represents the true beginning of the deeper climatic transformation the following months would reveal in full. Coral reefs, among the most sensitive ecosystems to sudden change anywhere in the ocean, faced within this first hour a combination of mechanical destruction from the surge and, more quietly, the earliest signs of thermal stress as water temperatures in shallow coastal regions began shifting away from the narrow range these organisms require. Reefs that had taken centuries to build faced, within a single hour, conditions capable of undoing that accumulated growth entirely. Freshwater lakes and inland seas, positioned far enough from any coastline to avoid the ocean's direct surge, nonetheless registered their own version of this hour's disruption. Large lakes, like the ocean, carry their own inherited momentum, and several of the planet's largest inland bodies of water experienced miniature versions of the same surging behavior, devastating the coasts smaller in absolute scale, but proportionally severe for the communities and ecosystems built along their shores, who had, in many cases, no reason to expect that a lake, of all things, could behave this way. There is a broader pattern beginning to emerge by the end of this first hour, one that would only become clearer as the following chapters unfold. Every system this scenario disturbs turns out to have depended on rotation in a way that was, until this hour, almost entirely invisible, not just the ocean's currents or the atmosphere's storms, but quieter, more distributed processes. The way heat moves, the way ecosystems time themselves, the way a magnetic field sustains itself far below the surface. An hour in, the planet had not yet revealed the full extent of that dependency. It had only begun to. Rescue and relief efforts, in any region still capable of organizing them, faced within this first hour a set of obstacles with no precedent in the history of disaster response. Ordinary relief work depends on stable infrastructure, functioning communication, and at least some predictability about what conditions responders will encounter. None of those assumptions held within this hour. Every road, every port, every airfield operating under conditions actively still deteriorating rather than settling into any accessible, static aftermath. Wildlife rescue organizations, in the rare cases they were able to operate at all within this first hour, encountered a version of triage with no established precedent to guided animals disoriented by wind, by displaced water, by the sheer unfamiliarity of a landscape reshaped within minutes, presenting injuries and behaviors that fell outside anything their training had ever prepared them to address. Even the most experienced responders, accustomed to storms and floods within the ordinary bounds of the planet's weather, found themselves working from instinct rather than protocol, because no protocol had ever been written for a disaster with this particular shape. By the end of the first hour, no coastline on the planet remained as it had been 60 minutes before. The atmosphere circled the globe in bands of extreme, continuous storm, still shedding momentum it had carried since before there was anyone alive to measure it. And in a place no one could see or record in real time, deep beneath the crust, a magnetic field that had shielded the surface from the harshest of the sun's radiation for billions of years had quietly begun the long, unhurried process of coming undone. The first day. Here, the scenario shifts in character. The first hour was defined by violence, wind, and water, converting stored motion into heat and damage, moment by moment, in a process that could at least be measured in the same units as an ordinary storm. The first day is defined by something stranger, and in its own way, more difficult to fully absorb: light and the sudden, permanent redistribution of it. Earth's day-night cycle has never depended on the sun's own motion. It depends entirely on the planet, turning to face the sun and then turning away from it, over and over, once every 24 hours. Remove the turning, and the cycle built on top of it does not simply pause and wait to resume. It transforms into something governed by an entirely different motion, the planet's orbit around the sun, a motion that continues, undisturbed and uninterrupted by anything that has happened to the planet's rotation. An orbit around the sun takes approximately 1 year to complete. With rotation gone, the only way a given point on Earth's surface can move from daylight into darkness is for the entire planet to travel far enough along its orbital path that the angle to the sun shifts meaningfully. This means a location facing the sun at the exact moment rotation stopped would continue facing the sun, would remain in unbroken daylight for roughly 6 months, as the planet completed half of its yearly orbit around the sun. The opposite hemisphere, in that same window, would remain in unbroken night for the same span of time. This is the detail that separates this scenario from nearly every other planetary catastrophe imaginable. It is not fast. It does not resolve itself within days or weeks. A day, in the ordinary sense of a single rotation from light into dark and back into light again, no longer exists anywhere on the planet's surface. What exists instead is something closer to a season, 6 months long, and, for the duration of that season, utterly unmoving. For the hemisphere locked into daylight, the first day of this new arrangement looked, in its opening hours, almost deceptively ordinary. The sun simply did not set, but the sun's failure to move across the sky, hour after hour, meant that the heat it delivered had nowhere to go. A single stretch of the planet's surface, without the relief of oncoming night, and without the atmosphere's usual rotational mixing to carry that heat elsewhere, began a slow and continuous rise in temperature that would not meaningfully reverse for months to come. By the close of this first day alone, equatorial regions on the daylight side had already crossed temperatures rarely recorded anywhere on Earth's surface in the whole of human history. Not because a single day of sunlight is in itself unusual, but because a single day that refuses to end is unlike anything the planet's climate system has ever been asked to absorb. On the night side, the opposite process had already begun. Without any sunlight at all, and without the atmospheric circulation that ordinarily redistributes heat from the day side to the night side over the course of a normal rotation, temperatures had already started falling toward levels associated with the coldest places ever recorded on the planet's surface. And this was only the first day of what would become 6 unbroken months of the same deepening darkness. Between these two hemispheres sat the terminator, the line separating permanent day from permanent night, a narrow band of the planet experiencing something like a fixed, unmoving dusk, neither fully lit nor fully dark. Here, the temperature difference between the sunlit and shadowed sides, in places separated by only a short distance, created some of the most powerful and sustained wind patterns anywhere on the planet, as hot air on one side and cold air on the other collided along a boundary that, unlike an ordinary weather front, was not moving anywhere, ever, day after day. The storms generated in the earlier hours of this event had not fully subsided by the close of this first day. They had, instead, changed character, driven now less by the planet's original loss of rotational momentum and more by this new and extreme imbalance of heat between hemispheres, an imbalance that would only continue to deepen as the months ahead unfolded. There is a stillness worth noting here too, away from the Terminator's endless wind. Far into the interior of the daylight hemisphere, in regions that had survived the initial violence of the first hour relatively intact, the first full day brought a different kind of unfamiliar quiet. No dusk, no dawn, no gradual softening of light toward evening, only the same unbroken brightness continuing hour after hour, a condition the human body, tuned by hundreds of thousands of years of alternating day and night, had no internal mechanism prepared to interpret as normal. The precise length of this new, orbit-governed day is worth stating carefully. Earth completes one full orbit around the Sun in a little over 365 days. With rotation removed entirely, half of that period, roughly 182 days, is the span a location facing the Sun at the moment of the stop would remain in continuous daylight before the planet's own orbital motion finally carried it into shadow. The same figure applies, in mirror, to the hemisphere plunged immediately into night. 6 months of light, 6 months of dark. And because Earth's axis remains tilted at roughly 23.5 degrees relative to its orbital path, even with rotation gone, the exact boundary of the Terminator would not stay perfectly still throughout that half year. It would drift slowly, following the same tilt that ordinarily gives the planet its seasons, so that the line between day and night crept gradually across certain latitudes, even while remaining fixed, for practical purposes, across most of the globe. For any surviving agricultural systems, this first day already carried consequences that would only compound as the months went on. Crops evolved over thousands of generations to respond to an alternating cycle of light and dark, some flowering only after a certain number of dark hours, others timing germination to the changing length of day across a normal season, found that signal simply gone, replaced by a condition their biology had no precedent for interpreting. Photosynthesis itself, dependent on light but also regulated by rest periods that align with darkness, would face an entirely new set of pressures under 6 unbroken months of either condition. Human circadian rhythm, tuned by hundreds of thousands of years of alternating day and night, offers a smaller, more personal window into this same disruption. The internal clock governing sleep, hormone release, and body temperature does not simply switch off in the absence of an external light cycle. It continues running on its own approximate rhythm for a time, drifting gradually out of sync with a world that no longer offers the light cues it depends on to reset itself each day. In the earliest hours of this permanent daylight or permanent darkness, this drift would have been barely noticeable. Over the months ahead, for anyone still measuring time by their own body rather than by a clock, it would become one of the more disorienting and quietly persistent effects of the entire event. In the ocean's uppermost layers, on the daylight side of the planet, photosynthetic plankton organisms responsible, collectively, for producing a substantial share of the planet's oxygen faced a first day of uninterrupted light that, at first glance, might seem beneficial to organisms that depend on sunlight to survive. But biological processes evolved around cycles, not constants, and many of these same organisms rely on periods of darkness to complete essential parts of their internal chemistry. Continuous light, rather than continuous benefit, represented for much of this microscopic life a first and disorienting break from a rhythm older than the plankton's own species. Solar energy infrastructure, wherever it had survived the physical destruction of the earlier hours, encountered a strange inversion of its ordinary operating conditions on this first day. Panels positioned to capture a normal daily cycle of rising and setting sun instead faced either constant, unmoving light or constant, unmoving darkness, depending entirely on which hemisphere they happened to sit within a system designed around variation now confronted with two opposite and equally unfamiliar extremes of constancy. Visually, the Terminator itself, in these opening hours, would have presented an image with no precedent in any sunrise or sunset ever witnessed on the ordinary Earth. Rather than the sun's position shifting gradually across the sky, producing the familiar gradient of color associated with dawn or dusk, the sun's position along this new and permanent horizon would remain essentially fixed, hour after hour, an unmoving line of light meeting an unmoving line of shadow, with none of the slow visual choreography a sunset ordinarily provides. The moon, throughout all of this, continued along its own orbit, entirely undisturbed, rising and setting relative to a fixed point on Earth's now motionless surface, according to its own roughly monthly rhythm rather than the planet's absent daily one. For observers on the permanently dark hemisphere, the moon would have offered the only remaining source of a cycle resembling anything from the world before a strange, singular reminder, moving steadily across an otherwise unmoving sky, that not every rhythm governing the heavens above had been lost in this event. The point on the planet's surface, directly facing the sun, what astronomers call the subsolar point, ordinarily sweeps continuously around the globe as the planet turns, tracing a new path each day, in a cycle repeating roughly every 24 hours. With rotation gone, this point became fixed, locked to a single location on the surface for the duration of the 6-month daylight period, moving only as slowly as the planet's orbital position and axial tilt required. A location fortunate enough to sit far from this fixed point, nearer the Terminator, would experience less extreme heat than a location positioned directly beneath it, where the sun would remain, hour after hour, day after day, at nearly the same position overhead, a detail that added its own geography of severity within the daylight hemisphere, distinct from the broader day-night divide already described. For the hemisphere plunged into permanent night, the stars overhead would have offered a spectacle no human observer had ever previously been able to witness in full. Ordinarily, the rotation of the Earth causes the night sky to appear to wheel slowly overhead, different constellations rising and setting as the hours pass. With rotation gone, the stars would instead have appeared to hold nearly still, fixed points of light barely shifting across the sky over the course of a single night. Their only movement, the very slow drift caused by the planet's continuing orbit around the sun, an unmoving canopy stretched across 6 unbroken months of darkness, changing only as gradually as the seasons themselves ordinarily change. The concept of a calendar, already complicated by the loss of time zones in the opening seconds of this event, lost still more of its practical meaning by the close of this first day. Months, weeks, and days had always been measured, in part, against the planet's rotation, against sunrise and sunset, against the alternation the whole of human timekeeping had been built around. With that alternation replaced by 2 6-month extremes, the very structure underlying a calendar would need, in the aftermath of this event, to be entirely reconceived, built instead around orbital position rather than rotational cycle, a change with implications reaching into nearly every human institution built, in some way, around the assumption of an ordinary day. Nocturnal animals, adapted over long evolutionary histories to hunt, forage, and move only under cover of darkness, faced on the daylight hemisphere a first day that simply never yielded the conditions their entire behavioral repertoire depended on. Some species possess enough behavioral flexibility to shift their activity patterns in response to changing light conditions within a single lifetime. Others do not. Their behavior governed by instinct so deeply fixed that no amount of environmental pressure within a single day could meaningfully alter it. For these more rigid species, the first day of unbroken light amounted to a kind of confinement, their entire way of engaging with the world rendered suddenly unusable. On the night hemisphere, the inverse applied to diurnal species, birds, and many mammals, whose vision, foraging strategies, and social behaviors depend on daylight. For them, the first day brought not confinement, but an abrupt and total halt. Activity patterns built around a sun that, for this hemisphere, had simply ceased to rise at all. There is an image worth holding from the close of this first day, quieter than the storms along the Terminator, a garden. Somewhere well within the daylight hemisphere's interior, its flowers still open, having no internal signal yet to tell them the day should be ending. They would remain open for weeks, and eventually months, an entire hemisphere of daytime blooms holding their unusual, unbroken position long after any ordinary evening would have closed them. Shadows, across the daylight hemisphere, offer one final detail worth noting from this opening day. Under ordinary rotation, a shadow's length and direction shifts steadily throughout the day, tracing a slow arc as the sun moves overhead. With the sun's position fixed, every shadow on the daylight hemisphere became fixed as well, locked into a single length and a single direction for the full 6 months ahead. The shadow of a tree, a building, a person standing still, no longer a marker of passing time, but simply a permanent feature of the landscape, as unmoving as the object casting it. Temperature records, in any surviving weather station capable of continuing to record them, would by the close of this first day already show a pattern with no historical analog to compare against, not the familiar daily rise and fall between a warmer afternoon and a cooler night, but a single, unbroken curve climbing steadily upward on the daylight side, and another falling steadily downward on the side left in darkness, each curve continuing without the slightest pause or reversal, hour after hour, for as long as this first day's conditions persisted. Along coastlines positioned near the Terminator itself, a strange hybrid condition emerged by the close of this first day waters still churned by the surges of the earlier hours, now overlaid with the beginnings of the Terminator's own distinct, thermally driven wind. These regions, caught between 2 different sources of extreme weather, experienced by nightfall of this first day a compounding of hazards unlike anywhere else on the planet's surface, neither fully defined by the original stopping event, nor yet fully shaped by the longer, slower climate transformation still to come. For anyone attempting to describe, in these earliest hours, what the planet's new geography of danger actually looked like, the Terminator itself would have to sit at the very center of that description, not the calmest place to be, as its position between two extremes might suggest, but very possibly the most volatile place of all. By the close of the first day, the planet had entered a condition with no precedent anywhere in its long geological history. Two hemispheres locked into opposite extremes, a boundary between them defined by permanent, unceasing storm, and an interior, far below the surface, continuing its own slow and entirely silent transformation. The months that followed. Months are where this scenario stops resembling a disaster in the conventional sense and starts resembling, in the most literal way, a different planet. By the second and third months, the daylight hemisphere had settled into a state of sustained, extreme heat. Without the relief of oncoming night, and without the mixing effect rotation had once provided to the atmosphere, surface temperatures in the most exposed regions climbed toward levels that would make liquid water difficult to sustain in open, sun-facing terrain. Oceans on this side of the planet did not boil away in the dramatic sense, sometimes imagined in speculation of this kind, but evaporation accelerated dramatically, thickening the atmosphere above the daylight hemisphere with water vapor and setting weather patterns in motion. Unlike anything present anywhere in Earth's climate record, storms fed continuously by a heat source that never diminished, because the sun above them never once moved from its position in the sky. The night hemisphere, across these same months, grew colder in a slower but no less relentless fashion. Without solar input of any kind, heat radiated away into space steadily, hour after hour, and surface temperatures in the darkest regions approached and then surpassed levels associated with the coldest places ever measured on Earth's surface. Ice began to form and spread across open water at a pace with no true precedent, because unlike an ordinary polar winter, there was no coming spring anywhere on the horizon to interrupt or reverse the process. The Terminator Band, meanwhile, had become the most dynamic region on the entire planet, not because it was hospitable in any meaningful sense, but because it was the place where the two opposing extremes met and contested each other continuously, without pause. Wind along this boundary did not calm as the months passed. If anything, the temperature difference between an increasingly scorched daylight hemisphere and an increasingly frozen night hemisphere grew larger, rather than smaller, with each passing week, and the winds driven by that widening difference grew correspondingly more severe in response. Deep beneath all of this visible upheaval, the slower process begun quietly in the first hour, continued its own patient arithmetic. Earth's magnetic field is generated by motion within the outer core, motion closely tied to the planet's overall rotation. Without that rotation, the dynamo process sustaining the field does not switch off in an instant. Its decay unfolds over a longer timescale, one likely extending well beyond the months this chapter can fully cover, stretching into years or longer still. But by these first months, instruments capable of detecting such changes would already have registered a field measurably weaker than the one the planet had carried, essentially unchanged for the whole of its geological history. A weakening magnetic field means a weakening shield against the constant stream of charged particles the sun sends outward in every direction. The consequences of that particular change would not become severe within the months this chapter describes. They would become severe later, over a longer horizon than this documentary can follow tonight, but the process, like so much else in this scenario, had already begun long before its full effects became visible to anyone standing on the surface. Life on the surface, across these months, faced a set of conditions with no precedent anywhere to draw from. Plants that depend on a day-night cycle to regulate their own growth and dormancy found that cycle simply gone, replaced by 6 unbroken months of one extreme condition or the other. Animals whose behavior is tied closely to daily rhythms, sleep, hunting, migration, the timing of reproduction found that rhythm not disrupted, but erased entirely from the world they had known. Some species, particularly those already adapted to extreme or unusual light conditions, organisms native to polar regions, where long periods of continuous daylight or continuous darkness already occur for part of every ordinary year were, unexpectedly, among the better positioned of all living things to endure what had become of the rest of the planet. This detail is easy to overlook amid the scale of everything else described in this chapter, but it matters. Adaptation, even inside the most extreme scenario imaginable, does not erase every advantage a species has already built over its own long history. It simply changes, quietly and without ceremony, which advantages happen to count. There is a particular kind of silence that settled over the deep interior of the daylight hemisphere by the 4th and 5th months. Not the silence of emptiness, but the silence of systems that had, in their own way, adjusted. Storms along the Terminator continued without pause, but far from that boundary, in regions that had absorbed the worst of the early violence and found some rough new equilibrium, the unbroken daylight had become, in its own unsettling way, simply the condition of things. Shadows did not move, the sun did not set, and whatever life remained had either found some way to endure the endless light or had not. Far below the surface turmoil, in the deep ocean, an entirely different story was unfolding across these same months, one defined less by catastrophe than by insulation. Ecosystems clustered around deep hydrothermal vents, kilometers beneath the surface, depend not on sunlight, but on chemical energy rising from the planet's interior, and these communities, remarkably, continued largely undisturbed by the chaos above them. The surface violence that had reshaped every coastline and divided the atmosphere into two opposing extremes barely registered at these depths, a reminder that not every part of this planet's living systems draws its survival from the same source or answers to the same set of rules. The polar regions, already accustomed under ordinary conditions to months of continuous daylight or continuous darkness, depending on the season, occupied a strange middle position in this new arrangement. Their pre-existing adaptation to extreme light cycles did not protect them from the extreme temperatures now developing on both sides of the Terminator, but it did mean that whatever species had already evolved strategies for coping with long stretches of unusual light, certain mosses, certain insects, certain hardy vertebrates, carried into this new world a set of tools better suited to it than almost anything evolved in more temperate, historically balanced latitudes. The ozone layer, high in the atmosphere, faced its own gradual complications across these months, tied loosely to both the breakdown of ordinary atmospheric circulation and the slow weakening of the magnetic field beneath it. Ozone is not created and destroyed at a constant rate everywhere on the planet. It depends on patterns of atmospheric movement that had, by this point, been substantially altered. On the permanently sunlit hemisphere, sustained solar exposure without the usual rotational redistribution of atmospheric gases created uneven ozone concentrations, thinning in some regions, concentrating in others, in patterns with no precedent in the planet's climate record to compare against. There is, in these months, a strange kind of dark comfort available to microbial life, if such a thing can be said to experience comfort at all. Bacteria and other microorganisms capable of surviving extreme heat, extreme cold, or extreme radiation, organisms already found in some of the most inhospitable environments on the ordinary Earth, from volcanic springs to the underside of polar ice, represent some of the toughest and most adaptable life the planet has ever produced. Across these months of unprecedented extremity, it was these smallest and least celebrated forms of life, rather than anything larger or more visible, that were best equipped by their own evolutionary history to simply continue. Atmospheric pressure patterns, across these months, settled into a configuration bearing little resemblance to anything in the planet's climate record. Under ordinary rotation, pressure systems organize into recognizable, relatively predictable belts, regions of consistent high or low pressure circling the globe at particular latitudes, driven in large part by the same rotational forces this scenario had removed. Without rotation, pressure instead organized primarily around the extreme temperature difference between the two hemispheres. producing a simpler but far more violent pattern. Hot, rising air on the daylight side, cold, sinking air on the night side, and a continuous, powerful circulation between them concentrated most intensely along the terminator itself. Soil health across the daylight hemisphere, subjected to months of unbroken heat with no relief, degraded steadily as moisture evaporated faster than it could be replenished, and the biological processes that ordinarily sustain fertile ground communities of microorganisms and fungi, tuned to a normal cycle of warmth and cooling, struggled to persist under conditions of unrelenting, unvarying extremity. On the night hemisphere, by contrast, the same soil faced a different but equally severe threat, as the biological activity ordinarily sustaining it slowed dramatically or ceased altogether beneath a deepening and permanent cold. Pathogens and disease vectors across these same months responded unevenly to the new conditions. Organisms adapted to narrow, stable temperature ranges. Many disease-causing bacteria and viruses among them found their usual environments radically altered, in some cases eliminated entirely by the new extremes, in other cases inadvertently favored by them, as the collapse of ordinary ecological checks and balances opened space for whichever organisms happened to be suited to the planet's strange new arrangement of permanent heat and permanent cold. There is a slower, quieter observation to make here, away from the specific mechanics of heat and cold and pressure. A planet, it turns out, does not require its rotation in order to continue existing. Gravity still held every ocean and every mountain in place. The sun still rose, once, and simply did not set on one half of the world, while the other half continued to look outward into an unbroken night sky, stars fixed and unmoving in a way no human observer across the planet's entire history had ever before been able to witness for more than a few hours at a time. There is something almost peaceful in that image, set apart from the devastation surrounding it, an unmoving sky, finally still, in the one place where stillness had never before been possible. Evolutionary pressure, across these months, operated with an intensity and a speed almost without precedent in the planet's long history. Ordinary natural selection unfolds gradually, across many generations, favoring small advantages accumulated slowly over centuries or millennia. The conditions of these first months instead applied pressure of an entirely different magnitude, conditions so far outside anything most species had ever encountered that the margin between survival and extinction narrowed, for many organisms, to a single trait or tolerance already present, by chance, within their existing biology, rather than anything that could be acquired through gradual adjustment in the time available. Cloud formation itself, across the daylight hemisphere, took on an unfamiliar character during these months. Under ordinary rotation, cloud patterns form and dissolve in relation to the daily cycle of heating and cooling, building through the warmth of afternoon and often clearing in the cooler hours of night. Without that alternation, cloud cover over the daylight hemisphere instead built continuously, thickening steadily as evaporation from the increasingly warm ocean surface fed a sky that never received the nightly cooling it would ordinarily have relied on to periodically clear itself. With the magnetic field measurably weaker than before, the aurora ordinarily confined to bands near the polar regions, where the field funnels charged solar particles down into the upper atmosphere began, over these months, to appear at far lower latitudes than history had ever recorded, a strange and genuinely striking visual consequence of an otherwise entirely destructive process, visible on both the increasingly cold night hemisphere and, faintly, even along stretches of the storm-racked terminator itself. There is a kind of symmetry worth noting between this scenario and the deeper history this channel has spent so much time following the mass extinctions, the sudden climate reversals, the long stretches where the fossil record goes quiet. Every one of those ancient events, too, was in its own way a story of some long-standing planetary constant being disturbed, and of life either finding a way to endure the disturbance or not. This scenario compresses that same fundamental story into months rather than millennia, but the underlying shape of it, equilibrium lost, and a long, uncertain search for whatever equilibrium might come next, is not new to this planet at all. It is, in fact, one of the oldest patterns Earth has ever known. Freshwater systems, across these months, followed their own distinct trajectory separate from the oceans. Lakes on the daylight hemisphere, subjected to continuous evaporation with no nightly cooling to offset it, shrank steadily, some disappearing entirely by the 4th or 5th month, their beds left exposed to a sun that never moved from its position in the sky. On the night hemisphere, by contrast, lakes froze from the surface downward, in some cases solidly enough, given sufficient time to threaten the survival of anything that had been living beneath the ice when the darkness first became permanent. Insects, taken as a whole, proved among the more resilient categories of life across these months, a detail consistent with their long evolutionary track record of surviving planetary upheavals far older and, in some respects, far more severe than this one. Their short generational cycles allowed a degree of rapid adaptation simply unavailable to longer-lived species, entire populations shifting their characteristics within a handful of months, in ways a species with a decade-long generational cycle could never hope to match within the same window. By the 6th month, as the daylight hemisphere finally approached the far edge of its long exposure and the first hints of an eventual, orbit-driven transition back toward darkness began to appear on the most distant horizon. The planet as a whole had absorbed nearly all it could of this particular phase of the disaster. What came after this point belonged to a longer story than this documentary can follow. Tonight, the slow swap of hemispheres, daylight giving way gradually to night and night to daylight, playing out across the following 6 months in a mirror of everything just described, before the cycle, if nothing else intervened, would begin to repeat. Migratory birds that had, months earlier, been caught mid-migration by the original stop and had somehow survived the initial chaos, faced across these later months a landscape offering none of the seasonal cues their migration had always depended on. Without a normal cycle of lengthening or shortening days to signal when to travel, many populations simply remained where they had found themselves when the disruption began, an entire category of behavior, refined over countless generations, rendered temporarily obsolete by the loss of the single environmental signal it had always relied upon. Fungal networks in the soil, largely invisible and rarely considered in discussions of surface catastrophe, registered their own quiet response to these months of extremity. Many fungal species depend on moisture cycles tied loosely to the same day-night alternation now absent across both hemispheres, and their gradual decline across the driest stretches of the daylight side represented a slower, less visible thread of the same broader unraveling, affecting every more visible layer of the planet's ecosystems above them. By the close of these first months, the planet had settled into something that could almost be called a new stability, not livable in the way the old world had been livable, not hospitable in any sense the planet's long history would recognize, but no longer changing moment to moment the way it had in the first violent hours. 2 hemispheres, opposite in nearly every measurable condition, a boundary between them defined by unceasing wind, and beneath it all, far out of sight, a magnetic field continuing its long, unhurried decline toward a threshold this documentary has not yet reached. When it started again, now we turn to the second question. What if, after roughly half a day of stillness, not months, not years, but the first 12 hours of this new and motionless world, the planet's rotation simply resumed, not gradually, the way a stopped engine might slowly regain speed. All at once, in the same manner it stopped, every layer of the Earth returning to its original rotational velocity in a single instant, as abruptly as it had been taken away. If the first stopping event was defined by everything on the surface continuing to move while the ground beneath it no longer did, this second event is, in almost every respect, its mirror image. In the 12 hours of stillness that preceded it, the ocean had begun, in places, to settle. The worst of the initial wind had, in some regions, started to ease as the atmosphere found a new, non-rotating equilibrium of its own. However violent and temporary that equilibrium remained, loose structures that had survived the initial catastrophe stood on ground that was, for the first time in half a day, no longer moving beneath them. And then, in a single instant, the ground began moving again, accelerating from zero back to its full rotational speed all at once, while everything resting upon it, having spent 12 hours slowly adjusting to a stillness it had never known before, was left behind by the sudden return of motion. This is, at its core, the identical physics of the first event, but with its direction reversed entirely. Where the original stop had thrown motion eastward, out ahead of the suddenly stationary ground, the sudden restart would throw everything westward. Relative to the now accelerating surface, the ground itself moving out from beneath anything that had settled into the half-day's uneasy calm. The ocean, having partially resettled into new coastal patterns over those 12 hours, would experience a second and entirely distinct set of surges. Water once again left behind as a surface abruptly resumed its motion beneath it. Structures that had survived the first event by virtue of unusually stable ground now faced a second test, this time arriving from the opposite direction, testing a different set of the same foundations in a way the first event never had. The atmosphere, too, would need to relearn its old rotational patterns not instantly, but through the same friction-driven process that had characterized the first hours after the original stop, only now running in reverse. Winds would once again reach extreme speeds as the lower atmosphere was dragged back into rotation by the now moving surface beneath it, while the upper atmosphere, still carrying the inertia of half a day's stillness, lagged behind, recreating the same violent shear that had defined the earliest minutes of this entire scenario. There is, however, a detail within this restart worth sitting with carefully, because it changes the essential character of this second event compared to the first. The Coriolis effect, the rotational influence entirely absent for the previous half-day, does not return gradually alongside the planet's rotation. The moment rotation resumes, the physics governing wind and ocean currents resumes with it immediately, reasserting all at once the deep planet-wide organizing patterns that had briefly fallen silent. Storm systems already in motion from the earlier chaos, patterns that had, in their own limited way, begun adapting to a non-rotating world, would suddenly find themselves subject to forces they had not experienced in half a day, forces that curve and redirect motion in ways the temporary stillness had never required of them. It would be, in its own particular way, every bit as disorienting to the planet's weather systems as the original stopping event had been. Not a return to normal, but a second transformation, layered directly and immediately on top of the first, with no interval of true calm in between. And the day-night cycle, having spent 12 hours locked entirely in place, one hemisphere still deep in what would have been merely the opening hours of its 6-month daylight, the other still in the opening hours of its 6-month night, would suddenly resume its ordinary 24-hour rhythm without warning. For the people, animals, and ecosystems that had spent half a day beginning, however painfully, to adjust to the idea of permanence, this sudden reversal would arrive not as relief, but as another abrupt and total change in the conditions they had only just begun to accept as the new and lasting shape of their world. What this second event tells us, more clearly than anything else in this documentary, is that there is no gentle way back from a change of this magnitude. A planet does not simply resume its old rhythms the way a paused clock resumes, ticking the instant it is wound. Every system disturbed by the original stop, the ocean, the atmosphere, the magnetic field far below, the daily rhythms of every living thing on the surface had begun, in its own limited way, adjusting to stillness across those 12 hours. Reversing the stillness does not undo that adjustment. It adds a second disruption directly on top of the first, asking the same shaken systems to reverse course entirely, with no more warning than they were given the first time. And, in many respects, with even less time to prepare for what was coming. For any living thing that had survived the initial stop, this second event would present a particular kind of biological cruelty, distinct from the physical devastation itself. The human circadian rhythm, only beginning its slow drift out of alignment with a world that had stopped offering ordinary light cues, would suddenly be thrust back into a 24-hour cycle without any of the gradual transition the body ordinarily uses to adjust across even a modest change, such as travel across a handful of time zones. This would amount to a disruption far beyond anything the phrase jet lag has ever been used to describe, not a shift of a few hours, but a whiplash between two entirely different relationships with light and dark, arriving with no warning and no means of gradual adjustment. The coastlines themselves, having absorbed one set of surges in the direction of the original stop, would now absorb a second set moving in the opposite direction, a geometry no natural coastline had ever been shaped by before. Sediment moved one way by the first event would, in many places, be moved back or redistributed further by the second, compounding the reshaping rather than reversing it. A bay that had been partially filled by the first surge might, in the second, be scoured out further still, or filled in additional, unpredictable ways. The coastline's final shape, a product of two opposing catastrophes, rather than a clean return to its original form. Tectonically, the crust would face a second period of stress almost immediately after beginning to settle from the first. The redistribution of oceanic mass during the 12 hours of stillness had already placed new pressures on fault lines around the planet. The second, reversed redistribution triggered by the restart would test many of those same fault lines again, this time from a different direction, in a shorter window than geological systems ordinarily have to absorb even a single such disturbance, let alone two in immediate succession. There is something worth carrying forward from this final chapter. Beyond the physics itself, a single catastrophe, however severe, at least offers a system something to adjust toward a new equilibrium, however harsh, that biological and physical processes can begin, however slowly, to work with. Two catastrophes, arriving in opposite directions within half a day of each other, deny even that. They ask every disrupted system to solve two different problems in immediate succession, with no confirmation that the second answer will resemble the first, and no assurance that adjusting to one has done anything at all to prepare for the other. Structures that had survived the first event, often through some combination of fortunate positioning and resilient design, face this second stress already weakened in ways not always visible from the outside. Materials fatigued by a first sudden shock do not require a second shock of equal magnitude to fail. A beam or foundation already stressed near its tolerance can give way under a load it would have withstood easily before the first event occurred. This is one of the quieter dangers of a double catastrophe arriving within half a day. The second blow does not need to match the first in raw force to cause comparable damage, because so much of what it strikes has already been brought closer to its breaking point. Animals that had survived the initial stop and had spent the intervening 12 hours beginning to establish new patterns of behavior suited to a world that no longer offered an ordinary day and night, faced a renewed disorientation with this second reversal. Not merely the shock of the restart's physical forces, but the deeper confusion of a world reverting, without warning, to a rhythm they had only just begun to unlearn. Behavioral adaptation, even in species capable of adjusting quickly, generally assumes some degree of stability in the conditions being adapted to. 12 hours offers barely enough time to begin that process, let alone complete it, and a second reversal arriving before adaptation could take hold left many species facing, in effect, two entirely separate crises, rather than one continuous one. It is worth asking, briefly, whether this second event would be the last of its kind, or whether a planet capable of stopping and restarting once might be capable of doing so again. Nothing in the physics of this scenario, taken on its own terms, suggests a natural endpoint to such oscillation if the mechanism behind the first stop and the first restart remains unexplained. There is no principled reason within the scenario itself to assume it could not recur a third time, or a fourth? This documentary does not attempt to answer that question because it lies outside the deliberately narrow window we have chosen to examine tonight. But it is a detail worth carrying quietly alongside everything else. A reminder that the stability we assume by default is not guaranteed by anything in this hypothetical world the way it is guaranteed, as far as we currently understand, in the actual one. There is also an asymmetry worth naming plainly between the stop and the restart, one that separates this final chapter from a simple mirror image of the first. The original stop acted on a world already fully adjusted to rotation every system, from the deepest ocean current to the smallest animal's internal clock, calibrated across immense stretches of time to a spinning planet. The restart, by contrast, acted on a world that had spent only 12 hours adjusting to the opposite condition, a far shallower adaptation than the one the original stop had disrupted. In this sense, the restart's disruption, though physically comparable in raw force, landed on systems with far less invested in the state it was interrupting. A small mercy, perhaps, buried within an otherwise symmetrical catastrophe, though scarcely large enough to be called comfort by anyone living through either event. What recovery might look like beyond this point lies past the boundary of what this documentary has set out to trace tonight. A planet that has stopped once and started again carries, in every rock formation, every reshaped coastline, every disrupted ecosystem, a record of both events layered together, indistinguishable from one another, to any observer arriving after the fact without knowledge of what had occurred. Whether stability, in any lasting sense, could re-establish itself after two such disruptions within a single day is a question this scenario leaves open, not for lack of curiosity, but because some questions are better left at the edge of what we can responsibly describe, rather than answered with more certainty than the physics actually provides. The magnetic field, having spent 12 hours in the earliest, gentlest stage of its long decline, would face in this restart an unusual question of its own. The dynamo process generating the field depends on motion within the outer core, motion tied to rotation. The sudden return of that rotation would, in principle, allow the dynamo process to resume as well, though whether it could return to its original strength immediately, or whether the field's brief interruption would leave some lasting imprint on its behavior going forward, is a detail that reaches beyond what 12 hours of disruption, followed by an instant restart, can definitively answer. It remains, like several of the deeper questions raised across this documentary, an open one. There is a final image worth holding on to, from this last chapter of Stillness Undone. Somewhere along the Terminator, in the last moments before rotation resumed, the wind driven by 6 months of imagined permanent day and permanent night would have been, for one brief window, beginning to show the faintest signs of settling, not calm, not anything close to safe, but marginally less violent than the hour before it. And then, in an instant, that faint settling was erased entirely, the planet's oldest rhythm reasserting itself all at once, indifferent to whatever small progress toward stillness the 12 hours before it had managed to achieve. For anyone who had spent those 12 hours believing, cautiously, that the worst of this event had already passed, the restart would arrive as its own particular kind of lesson that a system this large, disturbed this fundamentally, does not necessarily announce which of its changes are temporary and which are permanent. 12 hours had been enough to begin mistaking stillness for the new normal. The restart corrected that mistake immediately, and without any of the gentleness that correction might, under kinder circumstances, have been given. Whatever governments, communities, or organized relief efforts had managed, in those 12 hours, to establish some initial and fragile sense of coordination faced, with the restart, the collapse of that fragile progress, almost as quickly as it had been built. 12 hours is a short window in which to organize any meaningful response to a catastrophe of this scale. But it is not nothing early efforts to account for survivors, to identify safe ground, to begin the long process of assessment, however incomplete, had at least begun. The restart did not merely add new damage on top of the old, It erased much of the fragile order. The previous 12 hours had only just begun to assemble. There is little more to be said about this final chapter that has not already been said about the first. The physics repeats itself, almost exactly, only in reverse. And the toll it exacts does not diminish simply because the underlying mechanism has already been described once before. If anything, familiarity offers no protection here at all. A second sudden loss of the world's stability. Arriving on top of a first, the planet had barely begun to absorb, asking the same shaken systems to answer the same impossible question twice within the span of a single day. In the aftermath of this second event, the planet would not return, cleanly, to the world it had been the previous morning. Coastlines reshaped by two opposing sets of surges rather than one. An atmosphere that had been forced to relearn rotation twice within a single day. And somewhere far beneath the surface, a magnetic field that had only just begun its long decline, now left to determine, slowly and without any further instruction from the surface above it, whether 12 hours of interruption had been brief enough to leave no lasting mark at all. We began this documentary standing on ground, moving at nearly 1,700 kilometers an hour, a speed none of us has ever felt, because everything around us has always moved together, in perfect and unbroken agreement. That is the quiet truth resting beneath this entire scenario. The stillness we take for granted every day, without a second thought, is not stillness at all. It is motion so consistent, so perfectly shared between every object on the planet's surface, that it disappears from our senses entirely, leaving behind only the calm we mistake for the natural order of things. What we have followed tonight is what becomes visible the moment that shared motion is interrupted first violently, in the seconds and hours immediately after the stop, and then slowly, over the months of a world divided into permanent day and permanent night, each hemisphere drifting toward its own opposite extreme. And in the final chapter, we followed what happens when even the return to normal is not gentle, when a planet's attempt to resume its old rhythm becomes a second upheaval, layered directly on top of the first, offering no true interval of rest in between. None of this has happened, and none of it is expected to. The physics that would cause a planet's rotation to halt completely and then resume, all at once, has no known counterpart anywhere in nature, no precedent among the countless worlds astronomers have observed. But the question was never really about whether an event like this could occur. It was about what the answer reveals: that the planet beneath you is not a fixed and steady thing, quietly waiting out eternity. It is a system in careful, continuous motion, and everything you have ever called calm, ordinary, or unnoticed about the world around you is, in fact, that motion succeeding, quietly and without fanfare, every single day of your life. Every chapter of this documentary has, in its own way, been an argument for paying closer attention to exactly this kind of quiet success. Not the dramatic kind, not the kind that announces itself, but the patient, invisible kind. A planet holding its ocean in place, holding its atmosphere in place, holding an entire magnetic shield in place for 4.5 billion years, without asking for anything in return. We rarely think to thank a system for simply continuing to work. Perhaps, after tonight, that is worth reconsidering, if only for the length of one quiet evening. Somewhere above you tonight, the sky is turning at the same speed it always has. You will not feel it. You never have. And perhaps that is the quietest kind of privilege a world can offer its passengers, not the absence of forces large enough to end everything, but their patient, continuous balance, holding steady for so long, and so completely, that we forget there was ever anything to notice at all. There is no lesson here about gratitude, no instruction to marvel at the ordinary. The Keeper does not ask that of you. What this documentary offers instead is simpler than a lesson, a slower way of looking at something you already carry with you every day, without needing to think about it at all. The ground beneath you has always been in motion. It will continue to be, long after tonight, long after every person currently alive has stopped needing anything from this world at all. 4.5 billion years of turning lie behind this exact moment. 4.5 billion more, or something close to it, likely lie ahead. Somewhere in that immense span, this single night you have spent here is a small and ordinary thing, one more rotation among the uncountable many that came before it, and the uncountable many still to come. Tomorrow, wherever you wake, the sun will have moved across the sky the way it always does, not because it traveled, but because you did carried, gently and without your noticing, all the way around. It is not a small thing, even though it will feel, tomorrow morning, exactly as small and ordinary as it has felt every morning before it. That, in the end, is what a planet in good working order actually feels like from the inside. Not spectacle, not struggle. Just an ordinary day, arriving on schedule, the way it always has. Rest now. The turning continues, the way it always has. The way it will again tomorrow. And somewhere, right now, on the side of the planet still facing away from morning, it already has.